Okay, so now after binomial distribution, the next topic that we are starting today is Poisson distribution, right? Poisson distribution is used to calculate very minute probabilities, right? And that is done with the help of this formula, that is e to the power minus m upon m to the power r upon r factorial. Remember the formula that will be used in Poisson distribution, that is e raised to the power minus m to the power r whole divided by r factorial, where m stands for mean number of cases, r stands for favorable cases, while e stands for exponential constant. Remember, it is exponential constant and the value of e is always equal to 2.718. So remember the formula that will be used in Poisson distribution, that is e to the power minus m to the power r whole divided by r factorial, where m stands for mean number of cases, r stands for favorable cases, and e stands for exponential constant. The value of e is always equal to 2.718. Now take down a problem. With the help of an example, I'll explain what this Poisson distribution is all about. So write down a problem. On an average, 5 birds hit the Washington Monument and are killed every week. Full stop. Find the probability of less than 3 birds being killed in a week. Using Poisson distribution. In brackets, write down given e raised to the power minus 5 is 0.00674. So we are going to solve this problem using Poisson distribution. Now remember, m over here, the mean number of cases are 5. Just look at the first line of your problem. On an average, 5 birds hit the Washington Monument and are killed every week. So over here, the value of m is equal to 5. R, we are asking you the probability of less than 3 birds being killed in a week. So the value of R will be either 0 or 1 or 2. It should be less than 3, right? And what all values could be less than 3? Either R could be 0 or R could be 1 or R could be 2. Now we are going to solve each case one by one. First case, when R is equal to 0. So firstly, we will be solving a case whereby the value of R is 0. In the second case, we will take the value of R as equal to 1, and in the third case, we will take the value of R equals to 2. So we start probability of 0. First of all, let's take down the formula e to the power minus m m to the power r upon r factorial. Now m is 5 over here, so it will be e raised to the power minus 5. Then 5 raised to the power r is 0 upon 0 factorial. Now you know that in this question given the value of e raised to the power minus 5 is 0.00674. Anything raised to the power 0 is always equal to 1. This was explained to you previously, and 0 factorial is also equal to 1. This is mathematical formula, the value of 0 factorial is equal to 1. So we can say that the value of p probability when r is equal to 0 is 0.00674. Highlight this answer. This will be the value when r is equal to 0. Next, we solve when r is equal to 1. Now we see p raised to the power 1. We take down the formula, that is e to the power minus n, m to the power r upon r factorial. Now e raised to the power minus 5, n to the power r. So this is 5 raised to the power r. R over here is 1 upon 1 factorial. Further solving this, e to the power minus 5 is 0.00674. 5 raised to the power 1 is always 5 and 1 factorial is 1 only. So solve for 0.00674 multiplied by 5. How much you will get?
0.0337.
0.0337. This is the value when r is equal to 1. Kindly take down up till here, then we will solve further. This was p raised to the power 1, that is equal to 0.0337. So please take down the values up till here, then we will solve further. We have to solve one more case where the value of r is equal to 2. Initially we took the value of r as equal to 0, then r as equal to 1. Now third case, all of you know who have taken it down, start solving for the next one before we commence. Now r is equal to 2. Okay, so this was P0, please take it down 0.00674, P1 that is 0.0337. Now we will be solving the third case. The third case when r is equal to 2. The third case is when r is equal to 2. So first of all, we will take down the formula once again. That is e to the power minus n, m raised to the power r upon r factorial. Now m will remain 5. In this particular question, the mean number of cases are 5. Then 5 raised to the power 2 whole divided by 2 factorial. E raised to the power minus 5, then 5 raised to the power 2 upon r factorial. R factorial is 2 factorial. So when we solve it, we know that the value of e raised to the power minus 5 is 0.00674. You know that 5 square, it is equal to 25, and 2 factorial, that is 2 into 1. Right? You multiply 2 by 1, ultimately 2 factorial will be equal to 2 only. Now solve it. 0.00674 multiplied by 25 whole divided by 2. How much you will get?
0.08425.
0.08425. So we can say that e when r is equal to 2 is 0.08425. Now we have calculated the probability of each of these cases when r is equal to 0, r is equal to 1 and r is equal to 2. Now we will have to take down the final answer, and how we will get it? See, probability of less than 3 birds. It is P0 plus P1 plus P2. So we will have to combine all the values. Now P0 it was 0.00674. P1, it came out to be 0.0337, and P2, it came out to be 0.08425. Now solve it to give me the final answer.
0.12469.
0.12469. This is the final probability of less than 3 birds being killed in a week. Right? So whenever it is asked less than 3, you have to calculate the value of 0 as well as 1 as well as 2. And finally you will have to combine all these values to give the consolidated answer. Now one more thing before you take down this value. It was given in this problem the value of e raised to the power minus 5 is 0.00674. Now had it not been given, then you should know how to calculate the value of e raised to the power minus 5. And how can you calculate it? Taken it down, everyone? Okay. Now the value of e raised to the power minus 5. See, if you want to calculate the value of e to the power minus 5, you must know that we can make the power positive by bringing it down. It goes to the denominator, the negative sign will get converted into positive sign. Next, you must remember the value of e. It was explained to you initially, that was 2.718 whole raised to the power 5. Right? Now what do? You divide 1 by 2.718 and you press the equal to button 5 times. Right? What do you have to do? 1 divided by 2.718 and press the equal to button 5 times because the power is 5. And what are the result that you are getting? 5 times, after pressing it up. 0.00674. So e raised to the power minus 5, it is equal to 0.00674. Now the value was given. Even if it was not given, then you could have easily calculated the value of e raised to the power minus 5 by placing the value of e as 2.718. Right? Take down one more question to illustrate this problem of Poisson distribution. So please take down one more problem with the help of which you can easily understand Poisson distribution. Now write it down. An operator hires on an average 2 cars each day. On an average 2 cars each day. Full stop. Using Poisson distribution. Calculate the probability on a day when first point is no car is hired, and second point, 1 car hired. So second point is 1 car hired. Now how we'll have to solve it? First of all, just go through the problem and see what are the average number of cases over here. In this question it has been clearly specified. The operators hires on an average 2 cars each day. So the value of m will be equal to 2. Right? Now further, there are 2 different parts in this question. In the first part they are asking the probability of no car hired. So the value of r will be equal to exactly 0. Then there is a different part. In that part they are asking that what is the probability when only 1 car is hired. So the value of r will be equal to 1. So these are 2 different cases where you have to calculate the probability when r is equal to 0 and when r is equal to 1. But before that, let's see what will be the value of e raised to the power minus 2, because m over here is equal to 2. So you have to have the value of e raised to the power minus 2. Now first of all, let's take the power positive. That will be 1 upon e square. You know that the value of e is always 2.718. So it is 1 upon 2.718 raised to the power 2. Now do exactly what was explained to you initially. You have to divide 1 by 2.718 and press the equal to button 2 times only. And tell me what is the answer?
0.1353.
0.1353. So that's the value of e raised to the power minus 2, because it has to be used, while we are solving this particular case. So you know the value of e raised to the power minus 2. Now how will we start? In this case, the first part says you have to find out the probability when no car is hired. That means the value of r is equal to 0. Now P0, the formula stays the same. E raised to the power minus m raised to the power r upon r factorial. Now e raised to the power minus m is 2 over here. Then 2 raised to the power r is 0 upon 0 factorial. Now e raised to the power minus 2 was 0.1353. Explained to you initially. 0.1353. Anything raised to the power 0 is always 1, and 0 factorial is also equal to 1. So we can say that probability when no car is hired is equal to 0.1353. That's the answer of the first part. Now we move towards the second part. Now in the second part, the value of r is equal to 1, right? So we'll have to take down the formula once again. It is e to the power minus m to the power r upon r factorial. Now e to the power minus m will remain same, that is 2. Then 2 raised to the power r is 1 over here, and r again equals to 1 factorial. Now solving this, e raised to the power minus 2 is 0.1353. Explained to you initially. 0.1353 multiplied by 2 raised to the power 1 is 2 only, and 1 factorial will give you the answer as equal to 1. Now 0.1353 multiplied by 2 will give you the answer
0.2706.
0.2706. So probability that only one car is hired according to Poisson distribution will be equal to 0.2706. Now some students ask, sir, why don't we add, or combine the answers? See, that was only one part where you were asked to calculate the probability of less than 3 birds. So less than 3 indicated that you had to calculate the value of probability of 0, then probability of 1, then probability of 2. That's why you have to add all those cases. Now in this problem, these are 2 different parts. So we don't need to add it up, because in the first part they are asking you the probability of no car being hired, and in the second part they are asking you the probability of only one car being hired. So probability of no car hired on a particular day will be equal to 0.1353, and the probability of one car being hired will be equal to 0.2706. That's what Poisson distribution is all about.